Have you ever wondered how scientists interpret massive data sets with ease? Picture a vast ocean of numbers, each one representing a piece of information, yet appearing as an overwhelming deluge. This is the challenge that scientists often face when dealing with large data sets. With the sheer volume of data, it becomes crucial to find efficient methods to sift through and interpret this sea of information. Enter the logarithmic base 10 scale, a powerful tool in the data scientist's arsenal. It's a method that allows us to take a data set that spans several orders of magnitude and reduces it into a more manageable form. Essentially, it's a way of making big data feel a bit smaller, a bit more comprehensible. So, how does it work? Well, by using the powers of 10, the logarithmic base 10 scale transforms these massive data sets into a format that is far easier to understand and interpret. The key to understanding these massive data sets lies in the power of logarithmic base 10 scale. So, what exactly is this logarithmic base 10 scale and how does it work? Well, in the simplest terms, a logarithmic base 10 scale is a way to represent incredibly large or small numbers in a more manageable, comprehensible way. It's like a magic trick for math, turning huge, unwieldy numbers into neat, tidy powers of 10. Picture this. You're looking at a number with so many zeros it practically fills your screen. Daunting, isn't it? But with the logarithmic base 10 scale, we can tame this beast. We take the number's base 10 logarithm, which is simply the number of zeros after the 1. So a number like 1,000 becomes 3, 10,000 becomes 4, and so on. It's like we've compressed that long trail of zeros into a single digit. Now, let's see this wizardry in action with a real-world example. The Richter scale for measuring earthquake magnitudes. Earthquakes can vary tremendously in their power, from tiny tremors you can barely feel to catastrophic quakes that shake continents. If we used a regular scale, the numbers would be all over the place, making comparisons difficult. But the Richter scale is a logarithmic base 10 scale. This means that each whole number increase on the scale represents a tenfold increase in measured amplitude and roughly 31.6 times the energy release. So, an earthquake of magnitude 5 releases 10 times the amplitude and about 31.6 times the energy of a magnitude 4 earthquake. It's a smart way to make sense of something as wildly variable as earthquakes. And that's the beauty of the logarithmic base 10 scale. It transforms complex, sprawling data into a format that's much easier to understand and interpret. It's like a pair of mathematical spectacles, bringing the blur of big numbers into sharp focus. As you can see, the logarithmic base 10 scale transforms complex data into a format that is much easier to understand and interpret. But how does this scale interpret data in terms of powers of 10? Well, let's dive right into it. When we talk about a base 10 logarithmic scale, we're essentially saying that each step up or down the scale is a multiplication or division by 10. It's like climbing or descending a ladder where each rung is 10 times higher or lower than the one before. Let's illustrate this with a practical example, one that's all around us: sound. The decibel scale, used to measure sound intensity, is a perfect example of a base 10 logarithmic scale. When you're at a quiet library, the sound level might be around 40 decibels. In contrast, a busy city street might register at 80 decibels. Now, if you're thinking that a city street is twice as loud as a library, you'd be mistaken. Here's where the power of 10 comes into play. On a base 10 logarithmic scale, an increase of 10 decibels is not an addition, but a multiplication by 10. Therefore, the city street is not twice, but a whopping 10,000 times louder than the quiet library. Isn't that amazing? But why do we need to interpret data in this way? It's all about manageability and comparison. By converting numbers into powers of 10, we can easily handle, compare, and analyze vastly different numbers. Going back to our decibel example, it would be incredibly cumbersome to say that one sound is 10,000 times louder than another. Using the decibel scale, we can simply say it's 40 decibels louder. This method of interpretation is particularly useful in fields where data spans several orders of magnitude. It allows us to make sense of data that would otherwise be too large or too small to conveniently work with. So, by converting data into powers of 10, we can easily compare and analyze vastly different numbers. And that, my friends, is the power of 10. You might be wondering, Where else do we use this logarithmic base 10 scale? Well, it's not just confined to the realm of mathematics or data science. In fact, its applications are far more extensive, and they touch upon several other fields. Let's take a journey through the cosmos. In astronomy, for instance, it's used to measure star brightness. The difference in brightness between stars is so great that a linear scale just wouldn't cut it. With the logarithmic base 10 scale, we can capture this immense range in a much more manageable way. And guess what? It's not just the stars that benefit from this scale. The world of finance finds it incredibly useful too. When analyzing economic data, which often spans several orders of magnitude, the logarithmic base 10 scale comes in handy, helping us make sense of complex financial landscapes. Indeed, the practical applications of the logarithmic base 10 scale are as vast as the data sets it helps us interpret. To sum it all up, the logarithmic base 10 scale is a powerful tool, especially when dealing with large data sets that span several orders of magnitude. It allows us to compress vast amounts of information into a manageable and comprehensible form. When numbers become too big or too small, this scale makes them easier to understand and interpret. Remember, the logarithmic base 10 scale is all about powers of 10. It's a way to simplify complex data and make it more relatable. We've seen its application in various fields, from astronomy to music, highlighting its versatility and importance. It's also a great way to see and understand patterns that might otherwise be missed. So whether it's the magnitude of an earthquake, the intensity of sound, or the brightness of a star, this scale helps us to make sense of the world around us. So the next time you encounter a big data set, remember, the logarithmic base 10 scale is your secret weapon to make sense of it all.